Hello everyone. I can't get this camera right. Maybe one of these. Okay, that'll do. We've got camera steady. Okay. Well, I'm revising for my GCSEs. I got all my paper in front of me. Okay. Let's go over chemistry paper 1. Chemistry paper 1. Where have I? Oh. Okay. These are the topics for chemistry paper 1. Bonding, energy changes, chemical changes, and atomic structure and periodic table. That doesn't sound right. I feel like it's meant to be more. But I don't know if it's meant to be more. I feel like there is meant to be more. Surely there's more meant to be more. Energy changes, bonding. Not atmospheric chemistry. Not the rate of extent of chemical change. Not energy. I'm gonna hope there's only 4 topics, because if not, I'm fucked. Where should we start? Let's start with the one I understand least, chemical changes. This is a compressed version of everything I don't know on the topic. Okay, chemical changes. So the reactivity series. The reactivity series is pretty simple. It goes potassium, sodium, calcium, magnesium, aluminium, carbon, zinc, iron, hydrogen, copper, and silver and gold. That's it in order of decreasing reactivity. Only metals that are less reactive than carbon can be extracted via heating with carbon. So like a reduction reaction. This is my pen that I use, my Halloween pen. I use my Halloween pen for my Halloween revision, except it's not revision. But yeah, only metals. Oh, there goes the camera. Real. Okay. Only metals that you less reactive than carbon can be extracted via heating with carbon. Okay. Hello everybody. Oh, well, there's people here. Okay, so acid and metal make. Oh, there goes my thing again. There goes my camera again. Sorry, guys. 1 second. Okay, acids and metals make salts and hydrocarbons. Nope, hydrogen. Acid and metal oxides make salt and water. Everybody subscribe to me. Everybody subscribe to me. Just getting out there quickly. My exam is tomorrow in like 9 hours. Acids and metal hydroxides make salt and water. Okay, this is something I actually need to know. Acids and metal make salt and hydrogen. That's obvious, I think. Aqueous acids, that is. Acids and metal oxides make salt and water. Acids and metal carbonates make salt and water and carbon dioxide. Acids and metal hydroxides make salt and water. Thank you. I appreciate it. Metal oxides plus metal hydroxides make salt and water. Okay. To make copper sulfate crystals, you need a beaker, spatula, glass rod, Bunsen burner, tripod, gauze, funnel, filter paper, evaporating basin, and crystallization dish. You measure 50 centimeter cubed of sulfuric acid into a beaker, and you add copper oxide until it's in excess. And you'll know it's in excess when the reaction stops happening or copper starts building up. You then filter it to get rid of all the excess copper. Then you warm the filtrate until crystals appear, and you cool it in room temperature. And then, yeah, you've got your copper sulfate crystals because a displacement reaction happens. The sulfur gets oxidized and the copper gets reduced, I think. Acids produce hydrogen ions in a solution, and alkalis produce hydroxide ions in a solution. A pipette is for measuring a set volume of liquid. A burette has a graduated scale and adds in small increments. Okay, useful. Titration practicals are difficult. I find them difficult. You get a pipette and you measure a set volume of alkali into a conical flask. That's not too bad. You add a few drops of phenolphthalein indicator, which is clear when the pH of the substituent is less than or equal to 8.3, and goes pink when the pH of the solution is more than 8.3. And you add the indicator to the alkali and put the conical flask on a white tile. Then you fill the burette with acid and what does that say? And note the starting volume. You slowly add the acid to the conical flask, swirling. When indicator changes color, add acid drop by drop. Stop when the end point is reached. Repeat until concordant titra is obtained. Okay. You also should carry out a rough titra near the very start. It gives you a quick end result and allows you to be aware when to slow down in the future. Okay, and also something about the menesis, which is where when the liquid curves in a container, that's the menesis is the bottom of the curve, I think. Everybody subscribe to me, by the way. Do that, please. I'm trying to get back into doing YouTube and stuff after GCSEs. The effective strength of acid on pH. Stronger acid means a stronger ionization of an acid in an aqueous solution. Therefore, stronger acid equals lower pH, I think. Yeah, okay. An effective concentration. A higher concentration means more acid per unit of solvent, which means a higher concentration equals a lower pH. I think I get that. Concentration of a hydrogen ion in acid depends on whether acid is strong or weak, whether acid is concentrated or dilute as well. Weak acids only partially dissociate in a solution, shown by the symbol for irreversible reaction. An alternative current cannot be used for electrolysis as it would cause the electrode to swap polarity. Add the cathode if metal is more reactive than a hydrogen, for example, potassium, magnesium. Oh, what does that even say? Oh, thank you, I appreciate that. More reactive than hydrogen, what the fuck? I've written down the chemical solutions. No, the chemical symbols for the metals that are more reactive than hydrogen with K, Mg, and like F. Oh, Fe, iron. Okay, potassium, magnesium, or iron. If the metal is more reactive than hydrogen at the cathode, for example, potassium, magnesium, or iron, the metal will form. If not, hydrogen will form. And then at the anode, if the halide ions are present, for example, fluoride, chloride, bromide, or iodide, it will form. If not, oxygen forms. And I think that's just for when it's in an aqueous solution. I'll write that down. Rate my pen, by the way. I used to have these arms that would spin, but I ripped them off. Solution aqueous. Okay, that's all of chemical changes. That's 1/4 of the spec. Energy changes is a nice easy one. Energy changes is nice and easy. Reactions that are endothermic take in energy from the surroundings. This causes the temperature of the reaction mixture to decrease. After the reaction, the solution begins... Endothermic? I think I finally get it. Okay. Because exothermic and endothermic reactions. Exothermic reactions give off energy to the... They remove their energy and give it to the outside, so the outside heats up, and like the surroundings, but endothermic reactions take in energy from the outside, and I thought that meant that the solution itself or the reaction itself got hotter, but it doesn't, and in fact it means that they just have more energy. It's not necessarily thermal energy, it's like some other type of energy, so just everything's colder. Oh, thank you. Yeah. Good luck with it. Chemistry GCSE tomorrow, and then English Lit on Tuesday and English Language on Thursday. But then half-term holidays, a little bit of a break, which is nice. Endothermic reactions taking energy they're used commonly in cooling sports injury packs. Endothermic reactions transfer energy to surroundings used in... I actually don't know what that says at all. Hand warmers. I thought it said like it and warmers because I wrote the H wrong. Investigating reactions between a solid and an acid. Okay. Measure a known volume of acid into a simple calorimeter. Measure the. This is all shit I wrote myself, by the way. It's embarrassing that I'm struggling so much with it. Measure the acid's starting temperature. Add a set mass of base. What the hell's a base? Oh, base is an alkali. Base is an alkali that neutralizes an acid. That's a fun fact for you. Add a set mass of base and stir. Record the maximum temperature reached by the solution. And repeat tests with different masses of base. Okay, that's fine. That's not bad. Sorry, I'm just messing with my phone. One sec. My phone's gonna fall. Oh shit. There we go. Okay. Oh, the viewers are gone. Oh, we got one viewer left. Hi, viewer. For an total activation energy is the difference in energy between the reactants and the highest point in the curve. I know that. This is important. Total energy change equals energy needed to break bonds in reactants minus energy released when bonds are made. Oh man, I've written a message to myself when I made this. I wrote, come back to reaction profile energy changes. And it's way too late now to come back to it because it's just maths and I'm fine with maths, but it's this part of maths I find so difficult. So I just got to remember the formula and I'm probably fine, but it's stressful. For an electrochemical cell to produce a potential difference, the electrodes must have a reactivity difference, and the electrolyte must contain free ions, obviously. Methanol fuel cells considered over hydrogen fuel cells. Methanol is easier to store and transport. That's the scoop. Hydrogen has a low boiling point and is a gas at room temperature. It means it's harder to store as a fuel, as it takes up a lot of room and needs to be stored under high pressure. In a methanol fuel cell, CH3OH is oxidized to produce H2O and CO2. Okay. And then some maths on the back. Easy. I mean, not easy, very difficult. Okay. Let's do bonding, structure, and properties of matter. When metals and non-metals form ionic bonds, the metal gives an electron to the non-metal. Oh, I forgot all the. Oh, I forgot all this shit is on the tomorrow's paper. Fuck. It's been ages since I've looked at this. Okay. Metals and non-metals form ionic bonds. The metal gives an electron to the non-metal. But that shouldn't be that bad. I think I get how to do that. I know ionic bonds and stuff. The empirical formula is the simplest whole number ratio of the number of atoms of each element in the compound. That's fine. A covalent bond is formed when pairs of electrons are shared between two non-metals. Polymers are long molecules of repeating units, monomers, that are held together by covalent bonds. What? Covalent bond is formed when pairs of electrons are shared between two non-metals. Okay. So polymers that cannot be made of metals, I assume that's what that means. Metallic bonding is a regular pattern of positive metal ions located in a sea of delocalized electrons. During evaporation or boiling, particles gain energy, move faster, and intermolecular forces between particles are overcome. Yep. Solid to gas is called sublimation. Gas to solid is called disposition. If that's a niche fact. It probably doesn't end up coming up, hopefully. Sublimation and disposition. No, deposition. Okay. I need to dye my hair again. But I don't think I will. But look, that shit's... Wait, hold on. The roots are growing out quite a lot, I think. In chemical reactions, precipitates are insoluble solids, solutions of substances dissolved in a solvent that are aqueous, I guess. Ionic compounds have high melting points and are poor conductors of electricity. They do conduct when they're molten. I dropped a bit of Lego. Mount Everest ain't got shit on me. Simple covalent molecules have low moiling. Have low boiling. What's that say? Simple covalent molecules have low melting points and boiling points. Poor energy, electricity conduction, no charged particles, weak link to molecular forces, and strong covalent bonds. Okay, that's fine. That doesn't make too much sense to me. Polymers are very large. Oh, I don't want fucking Lego. Mount Everest ain't got shit on me. Polymers are giant covalent molecules made of repeating units, bonded with covalent, strong into molecular forces, strong at. How does RT mean? I've just wrote strong at R, solid at RT. Happy birthday. Nice. What could solid at RT mean in the description of polymers? Room temperature. They're solid at room temperature. Okay. Giant covalent structures are non-metals. They're high melting points and boiling points and don't conduct electricity and are insoluble. Hello everybody. We've got a lot of viewers right now. Hello everybody. Subscribe to me, please. That would be good. Thank you. Please. Oh, this is the difficult one. About carbon structures. Polyethylene. This is I think that's right. Polymer ethene is a polymer that doesn't conduct electricity and is solid at room temperature. Graphite is a giant covalent structure that is electrically conductive and is also solid at room temperature. Diamond is a giant covalent that isn't electricity conductive and is solid at room temperature. Silicon dioxide is a giant covalent that is not electrically conductive and is solid at room temperature. Okay. An alloy is a mixture of a metal with one or more other elements. Diamond has a giant structure. I gotta add something to that. Thermal metals due to no sliding layers due to disrupted layers. Awesome. Diamond has a giant structure where carbon atoms are held together by strong covalent bonds. I'm not remembering any of this. It's just not going into my head. This is bad. The exam's like, what time is it now? It's 11:30. So this is not what I should be thinking about right now. 11:30. 9 hours to it's 9 hours till the exam. I'm obviously going to sleep, but like I don't know. I've had way too much like caffeine today. I can't focus. Buckminster fullerene, graphite, and graphene are each have carbon atoms bonded to three other carbon atoms. Graphene is a simple layer. Graphite has many layers. I have no clue what this is about Buckminster fullerene. Like CC or something? No idea. Nanoparticles have diameters between 1 and 100 nanometers. They're 100 times larger than atoms and simple molecules, smaller than polymers. Nanoparticles are good catalysts as they have a high surface area to volume ratio. Okay, that's another one done. Almost done with chemistry paper 1. Now I've got atomic structure and the periodic table. A mixture consists of two or more elements or compounds that are not chemically bonded. Distillation uses a piece of equipment called a condenser. This uses cold water to cool down any gas that passes through it. Okay. Since simple distillation separates substances. What a fucking banger, by the way. Since simple distillation separates substances. Simple distillation separates substances. What a banger. Say that 5 times fast. According to their boiling points, it cannot separate substances with similar boiling points. Okay. Niels Bohr adapted the nuclear model to suggest electrons orbit the nucleus at specific distances. James Chadwick provided evidence for the neutron. Isotopes of an element have different numbers of neutrons. Isotopes of an element have different numbers of neutrons, but the same number of electrons and protons. Different isotopes have the same electronic configuration. They have very similar chemical properties. Relative atomic mass equals total mass of atoms divided by total number of atoms. Okay. Electron configuration tells you the number of electron shells within the period number, the number of electrons, protons, and atomic number, and the group number. Awesome. In the modern periodic table. Oh man, I'm tired as hell. In the modern periodic table, elements are. Oh, my phone's on 10%. Shit. It's my. Oh, my fucking. Oh no, I've fallen over. My fucking tripod's broken. I don't know how to fix it. Hold on, I'm breaking the fourth wall here. This is my tripod that I use for light, and it also has a bit to hold the phone, which is really useful. But, slight issue, it only has 2 legs because one of the legs has fallen off, and I just don't know how to fix it at all. I'm never really good with glue or anything, and I don't know where the other leg's even gone. Oh, it's such a pain. I'm just going to buy a new one. Fuck it, I'm actually just going to buy a new one. Because I've got a really nice tripod, but it doesn't have a light attached to it, and this one has a light attached to it, and it's really useful. Hold on. Oh my gosh, it's such a pain. I can't even plug my phone in and have the, Oh. Wait a minute. Yes! Oh no. Wait, the tripod's falling over. Yes, okay. We've got an angle now. My phone's still gonna die soon. You know, let's finish this. I've got 9%. I'll finish this. And then go to bed. I've got no idea when the chemics are is, unfortunately. In the modern periodic table, elements are arranged by increasing atomic number in atoms, I think. Rows are called periods, correspond to the number of electron shells. Columns are called groups, which correspond to the outer shell electrons. 1817, Dobereiner talks about triads. 1865, Newland publishes the law of octaves, saying every 8th element had similar properties. 1869, Mendeleev publishes early periodic table, leaving room for undiscovered elements, group elements with similar properties together. 1917, Rutherford discovers the proton. I have heard of TikTok Live. I don't know how to do it, though. I don't know how to do it. And I've got more followers on YouTube, more subscribers on YouTube than followers on TikTok. So it means I have a wider reach, which is better. I like YouTube more than TikTok anyway. Modern periodic tables have longer periods towards the bottom. Mendeleev squeezed elements in staggered columns. That was bad. As you go down group 0, noble gases, the boiling point of noble gases increase. Alkali metals are lithium, sodium, potassium. Why have I written this down? Nitrogen plus water equals... No, what does that say? Sodium plus water equals sodium oxide plus hydrogen? Yeah, obviously. Halogens, group 7, alkali metals, group 1, noble gases, group 0. As you go down group 7, melting point and boiling point increase, relative atomic mass increase, metals react with halogens to form metal halides, reactivity of halogens decreases down the group. In displacement, more reactive halogens replace a less reactive one. Okay. Metals have giant metallic structures, halogens have small molecules of 2 atoms. Metal halides have giant ionic structures, transition metals equals middle. They're just the middle things. Okay, that's chemistry done. I'm going to see if I can... Oh, it just drains your battery, the going live. I mean, obviously it does. I've got some Inspector Calls quotes, actually. We could have a quick look at those while I've still got some battery. Or I could just go to bed. I don't know. Let's go through quick ones. Quick ones. Here's some themes for Inspector Calls. All the themes are social responsibility, generational divide, gender, and class. We got social responsibility. Sheila Burling says, "All right, Gerald, you needn't look at me like that. At least I'm trying to tell the truth," which she's taking responsibility and, tells the truth. Gerald judges despite not taking responsibility and not telling the truth. Mr. Burling says, "If we were all responsible for everything that happened to everybody, if we were all responsible for everything that happened to everybody we'd have anything to do with, it would all be very awkward." He dismisses the idea of social responsibility, reflecting a capitalist mindset. Eric says, "You lot may be letting yourselves out..." I've got no idea what that says. That just looks like a scribble. "You lot may be letting yourselves out nicely, but I can't." He has social responsibility and he tells his mother to be responsible too, showing a bravery and also separating him from the older generation. Sybil Burling says, Eric, I'm absolutely ashamed of you. She doesn't have social responsibility, and she's ashamed of Eric for having social responsibility. Again, showing a divide. And the inspector says it's better to ask for the earth than take for it, which contrasts Mr. Burling's quote of, I can't find it. If you don't come down sharply on some of these people, they'd soon be asking for the earth. Okay. Generational divide. Eric and Sheila, they say you're beginning to pretend now that nothing has really happened at all. Suggests, after the rest of the Burlings said that the inspector wasn't real, they're pretending it's not true. They Eric and Sheila hold on to the idea that even if it wasn't real, the message he delivered was true, and they needed to focus on being better, showing which the other lot don't say. So it shows a generational divide. Mr. and Mrs. Burling say, so I was perfectly justified in not advising my committee not to allow a claim for attention. They are unmoved, like contrasting the younger generation who are moved by the inspector. What's my phone battery at? 5%. Okay, I'm just going to finish this sheet and go to bed. The famous younger generation who know it all. That's what Mr. Burling says, and he's like making a mockery. He's talking down. Again, he's not. And then, why you historical young fool? Get back, or I'll. Burling calls Eric a young fool. Burling tries to go to violence, showing that he's more foolish. But again, it's like the gap. Gender, the theme of gender. Mr. Burling says to Eric and Gerald, not only to make him look prettier, but sort of sign and token of their self-respect. He has a patronizing view, stereotypical views of women, and like dehumanizes them. Gerald says, I hate those hard-eyed, dough-faced women. He's superficial. Miss Burling to Eva Smith says she was claiming elaborate fine feelings and scruples that were simply absurd for a girl in her position. She's just as cruel and old-fashioned as men, showing that doesn't really show much for gender, but it shows the wealth and class gap. Speaking of class, we've got the theme of class. Burling says if you don't come down sharply on people, they'll soon be asking for the earth. He feels responsibility to punish people as part of the upper class. The divide again, which also contrasts the inspector saying it's better to ask for the earth than take it. Gerald says he's a notorious womanizer as well as being one of the worst sots and rousers in Brumley. The Burlings have shock that like the upper class can behave poorly, showing that I don't know what that shows. I'm fucked. Sybil says, as if a girl of that class would ever refuse money, she has a false perception and prejudice towards lower class people. Bam! That's 30 minutes of revision. Bye!